tech enthusiasts. Today we're diving deep into the fascinating world of microchip production. Have you ever wondered how those tiny but powerful devices that power our smartphones, computers, and more are actually made? Well, you're in for a treat as we're about to break down the complex process into simple words. By the end of this video, you'll have a clear understanding of how microchips are manufactured. So let's get started. Before we delve into the manufacturing process, we'll dive into the history of microchips. Microchips, also known as integrated circuits or ICE, have a rich history dating back to the mid-20th century. In 1958, Jack Kilby at Texas Instruments built the first functional integrated circuit, a breakthrough that laid the foundation for modern microchips. Kilby's invention combined multiple electronic components onto a single semiconductor substrate. In parallel, Robert Noyce, co-founder of Intel, developed a similar integrated circuit concept, but with the addition of a layer of metal to connect components. This innovation, known as the planar process, enabled mass production of integrated circuits. The microchip's significance grew rapidly. In the 1970s, the introduction of microprocessors powered by microchips revolutionized computing. This led to the development of personal computers and eventually the digital age. The 1980s and beyond witnessed advancements like the very large-scale integration process, allowing more components to be packed onto a single chip. This enabled the creation of more powerful and efficient electronics, from smartphones to medical devices. Moore's law, proposed by Gordon Moore in 1965, accurately predicted the continuous miniaturization and increased performance of microchips over decades, becoming a driving force for innovation. Today, microchips are ubiquitous, powering everything from everyday devices to complex systems like artificial intelligence and self-driving cars. The history of microchips reflects a remarkable journey of innovation, transforming the world through ever smaller, more powerful electronic components. Let's quickly cover the basics. A microchip, also known as an integrated circuit, is a small electronic device made from a semiconductor material, usually silicon. It contains transistors, resistors, and capacitors that work together to process and store information. The first step in microchip manufacturing involves creating a silicon wafer. Think of this wafer as the canvas on which our microchips will be built. Pure silicon is extracted from sand, then heated and purified to create a cylindrical ingot. This ingot is then sliced into ultra-thin wafers using precision cutting machines. Now that we have our wafer, it's time to ensure its cleanliness. Wafers go through multiple cleaning processes to remove any impurities and particles that could affect the chip's performance. This cleaning is crucial as even a tiny speck could impact the functionality of the microchip. Next, a series of complex processes known as photolithography come into play. A light-sensitive material called a photoresist is applied to the wafer. Then, a mask with the desired circuit pattern is placed over the wafer, and ultraviolet light is used to transfer the pattern onto the photoresist. This pattern serves as a blueprint for the various layers of the microchip. After the pattern is transferred, the wafer goes through etching, where specific areas of the photoresist are removed. This exposes the silicon underneath. Then, different materials are deposited onto the wafer's surface through processes like chemical vapor deposition or sputtering. These materials form the various components of the microchip, such as transistors and interconnects. Now comes the doping process. By introducing specific atoms into the silicon, the electrical properties of the material can be altered. This is crucial for creating transistors, which are the building blocks of microchips. The controlled introduction of these dopant atoms allows for the creation of N-type negative and P-type positive regions, forming the basis of transistor functionality. The process of layering, etching, and deposition is repeated multiple times, creating intricate structures layer by layer. Insulating materials are added between these layers to prevent unwanted electrical interactions and short circuits. Once the individual components are in place, it's time to connect them. Thin layers of metal, usually copper, are deposited onto the wafer. These metal layers are patterned to form interconnects and wiring, allowing different parts of the microchip to communicate with each other. With the microchip's components in place, rigorous testing and quality control are carried out. This helps identify any defects or issues that might have occurred during the manufacturing process. Chips that pass these tests move on to the next step. The final step involves packaging the microchips. Each chip is placed in a protective casing to shield it from environmental factors. Then, comprehensive testing is conducted once again to ensure that the chip functions as intended. Only the chips that meet the strict quality standards move on to distribution. Over the years, one of the most impressive feats in microchip manufacturing has been the constant push for miniaturization. The Moore's Law principle, coined by Gordon Moore, predicted that the number of transistors on a microchip would double approximately every 2 years. This prediction has largely held true, leading to the creation of more powerful and compact devices. As we've continued to shrink the size of transistors and components, traditional photolithography techniques have faced challenges. This is where extreme ultraviolet lithography EFE comes into play. UV uses ultraviolet light with incredibly short wavelengths to create even smaller patterns on the silicon wafers, allowing for the creation of more advanced and powerful microchips. Child silicon-based microchips have dominated the industry. Researchers are exploring alternative materials and technologies. One exciting area is quantum dots, tiny semiconductor particles with unique quantum properties. These dots could potentially revolutionize computing by enabling quantum computers that perform complex calculations at unprecedented speeds. With the growing demand for electronics, there's a growing concern about the environmental impact of microchip manufacturing. The process requires a significant amount of energy and water, and it generates various types of waste. Manufacturers are working on more sustainable practices, such as reducing water usage, improving energy efficiency, and recycling material. The microchip industry is a global endeavor, with different stages of manufacturing often taking place in different parts of the world. However, recent events such as the pandemic and supply chain disruptions have highlighted the vulnerabilities of this interconnected system. These challenges have led to discussions about restoring and improving supply chain resilience. As we wrap up our exploration of microchip manufacturing, it's important to realize the pervasive impact these tiny devices have on our daily lives. From smartphones and laptops to medical devices and transportation systems, microchips are at the heart of nearly all technological advancements. Before we conclude, let's address some of the questions we've received from our viewers about microchip manufacturing. Feel free to leave more questions in the comments below, and we'll do our best to answer them in future videos. Learning about the intricate process of microchip manufacturing is a reminder of the incredible innovation happening behind the scenes of our devices. So whether you're an aspiring engineer, a tech enthusiast, or simply curious about the world around you, remember to keep learning and exploring new frontiers. And there you have it, the simplified journey of how microchips are actually made. From the creation of silicon wafers to the intricate processes of layering, etching, and wiring, it's truly amazing how these tiny devices are manufactured. We hope this video has shed some light on this complex process. If you found this information as fascinating as we did, don't forget to like and subscribe for more tech-related content. Thanks for watching, and until next time, stay curious.